Okay, it's 3 o'clock. What's going on? It's the second show today on November 16th. I'm your host, Hugo Fernandez, here on LaGuardia Web Radio, WLGR. And my guest today is Dr. Nathan Hosannah, who is an assistant professor in the Math, Engineering, and Computer Science department here at LaGuardia Community College. You want to say hi, Nathan?
Yes, peace to you all. Thank you for having me, Hugo. Great to be here.
Uh, Nathan and I met years ago at a one of those new faculty welcoming events at the grad center on the Skylight Cafe. Back when I guess we could all get together, and the groups are still large enough, and we got our picture taken with. At the time, I think I can't remember if it might have been Milliken, but it might have been Vita, who was the interim vice chancellor. Do you remember? Do you still have that picture?
I do. I believe it was Vita, actually.
Yeah, Vita was our interim chancellor, and she was good at the time. And I said, Vita, come on over here. And but at that time, I think I don't know if it was then that we said we should do a show, and here we are, several years later. And
There were quite a few correspondences between you and I.
yeah,
So we got here. Yeah.
so we're making it happen. Nathan, you want to talk a little bit about yourself, your background, and your studies?
Yeah, man. So do you want me to go into the details or the details?
Well, it's your show. We've got an hour, so feel
All
free.
right. All right. So background. My parents are from Guyana, which is the only English speaking country in South America, but it's a Caribbean country as well. So all of the culture is very similar to Trinidad, to Jamaica, to Barbados, Grenada, and all those places. So my parents are both from Guyana. However, they didn't meet each other in Guyana. They separately flew to England to begin their lives as very young people, and they met over there. Had three of my brothers. Well, I only have three brothers, so they had all three of
Right.
my brothers, and then me. I'm the youngest. And at the ripe young age of 3 years old, going on 4, the family moved, and I was then raised in Queens, New York. And so,
Wild.
yeah, so it's a journey. So I every time someone asks me this, I always have to go into the details of the ancestry in a sense, and like where I hail from for real.
But yeah, from your accent, you would never know that
I
you
know,
grew up in England or South America.
right? Exactly. So because New York has such an influence on us,
Yes.
and even people who have been here for shorter periods of time, you may not necessarily be able to determine where they're from. And as I came to the United States, my brothers are connecting to hip hop culture and the music that is generating the impetus around that time. And I'm listening to this as well. And so this is forming my expression in the way
Right.
that I talk and the way that I pronounce things. But it's funny because my family members now and the ones that aren't from England or weren't born in England, now they will still say that they can grasp that I was born in England by the way that I say certain things.
Uh, like aluminum
Al- Aluminum, yeah.
or
One of my,
aluminium, whatever they say.
yeah, right, exactly. One of my brothers actually says H instead of H, and that's an example of it.
Oh, really?
But even the word choices, the things that I choose to say and the way that I express myself,
Yeah.
people do not think is really indicative of someone who was raised here, and I really don't know what that means.
Yeah. I'll tell you, the older you get, you start picking up on it. And my mother used to say that the older you get, you return to the language of your origin, which
Mhm.
believe it or not, my first language was Spanish. I mean, we spoke nothing but Spanish in the home. I didn't start speaking English until I found myself, in daycare, which happened to be an African American daycare center in Coconut Grove, Florida.
Mm,
So I spoke, as a child. When we moved to New York, I spoke English like a Southern black child, which kind of threw everybody off. And when I say to my sister, what's up with your brother? Like, why does he talk like that?
mhm.
And then I had the New York thing, and then I moved to Boston. I had the Boston thing. By the time I got to Florida, and I lived in different places before that, now I'm from nowhere. Like nobody knows what's up with
Exactly.
my
Yeah.
accent. And my
You,
Spanish suffered as well because I didn't get to keep it up either at home or in school. So my Spanish is that of a 5-year-old child, pretty
that
much.
kind of that's interesting to me because I would imagine that, especially in New York, that there, to my understanding, there's always a large population of people who spoke Spanish. I'm
Well,
not sure how it was in the school system back then.
I grew up in when I was as a kid. I lived in Inwood, and
Gotcha.
this was
Okay.
before the influx of the Dominican population. And I mean, there are a lot of Cubans actually in that area of Manhattan when I was here, and I'm talking about like the late '60s.
Mhm.
And then, uh, well, like I said, I lived in Boston, but we lived. My mother had this habit of finding nice neighborhoods, or finding inexpensive neighborhoods next to nice neighborhoods that had good schools. And
Mhm.
so we were always in this kind of peculiar no man's land growing up as a kid. So, and I, but I got to go to some good schools. Where did you study when you went to school?
So I studied. So I like to start from the high school level
Sure.
because it's close to where LaGuardia is. I went to high school at Aviation High School,
Oh, very good.
and that kind of connected my desire to do. It connected to my desire to do engineering to understand more of the theory because aviation was really hands-on, and there was some theory connected to it, but I wanted to delve in deeper and
Yeah, I think
have both of these skill sets.
yeah. Right, aviation was the notion was you would learn skills that you would then be able to go to LaGuardia Airport and get a
Exactly.
job fixing. I don't know what, like fixing engines or something, fixing
Fixing engines,
airplanes.
fixing both the airframe and the power plant, where the airframe is the actual body of the aircraft, and then the power plant is the things that actually run the things that run the aircraft.
Right.
So yeah, so there was heavy, heavy, heavy dedication to learning that skill set.
Right.
After that, I went to City College, actually, City College of New York for undergrad, and I studied mechanical engineering. I didn't want to go straight to work for the airlines. I wanted to learn more. I wanted to stake in the process of seeing what else I could connect to from an engineering standpoint.
Were your parents, did they go to college?
No, but my mother went to nursing school.
Okay.
So my mother went to nursing school, and for another thing, something that relates to the idea of my parents and what I done is that I am someone who does not particularly connect to any one religion.
Right.
But as I was coming up, my mother was a Jehovah's Witness.
Well, you have your last name is
Yes,
pretty
yeah,
intense.
which is funny, right? I know.
Oh no,
Yes,
it just is. And I was trying to think if I knew anybody else who had that. But it's a pretty impressive name.
thank you, sir. Go to Brooklyn. You'll see. You'll hear of
I'll,
a lot
I'll
of
find more of
Hosannas.
them, more
Absolutely.
hosannas.
Yes, absolutely. So I bring that up to say that in my upbringing, as my mother was a Jehovah's Witness, the maneuver was to develop a trade and to
Right.
use that trade to then benefit the kingdom of God.
Right.
From her perspective,
Uh huh.
from my perspective, it wasn't that at all. And so that led me to kind of make that jump from aviation into City College and continue my learning.
And did you get your PhD there?
I got my PhD through at City College, but via the grad center because the grad center at that time was the PhD granting institution in engineering within CUNY.
Okay.
Now, City College has PhD program, so
And it was it in mechanical engineering as well?
it was in mechanical engineering, but the focus was atmospheric science. So when you think about weather and climate, you may not necessarily think about a automobile engine, but the Earth system is an engine. It has thermodynamics, it has heat transfer, and there are things that relate to the motion of different fluids. And those three components are necessary for the understanding of mechanical engineering. So I was able to shift over and go into the study of the Earth system from that knowledge.
So if you were to say, what your focus is and your studies and obviously your scholarship, what is
Mhm.
that? What is that particularly?
So my focus is how multi-scale environments impact rainfall as well as dry spells in different regions. When I did my dissertation, the focus was on aerosols, which are these very small particles that can suspend in the clouds and alter the chemistry of the cloud and alter the spatial distribution of rainfall over an area. So I wanted to see how by modifying the size of the aerosol and the concentration of the aerosols over New York City, how that would change local and larger scale rain events. And then after that, I said, you know what? I need to expand this. I don't want to just look at aerosols. I want to look at wind. I want to look at temperature. I want to look at how proximity to water, so Atlantic Ocean, Caribbean Sea, for example, may also impact humidity and the advection or transfer of moisture from one area to the next. So I expanded to this more holistic, multi-scale impact, meaning from the local scale and the larger scale impact of Saharan dust, of wind, of pressure, of aerosols on local weather environments. So I focused a lot over the last years on Puerto Rico, but I'm also now beginning to look at Guyana as well. So I'm doing both observational and modeling experiments in the case of Puerto Rico, but in the case of Guyana, that is modeling experiments. I have a few students working with me to achieve that.
It's an interesting time considering what's been going on with the number of hurricanes that have been happening, which of course begin with the Sahara winds moving into the mid-Atlantic, and then what becomes the tropical depressions based on the temperatures of the ocean and all the other factors, low pressure, high pressure, that then become these catastrophic weather events that when I was a kid in Florida, I always say this, when I was a kid in Florida, the first 5 years of my life, there was a hurricane every year. My mother would remember them, remembered every one of them, because they were very frightening. And then we moved to New York and Boston, and we moved back to Florida. There were no hurricanes for 20 years.
Mm,
And then when I left for graduate school, like the second year I left for graduate school, I'd come back to get a bunch of stuff in a car. And as I drove out of town, I was being chased by Hurricane Andrew.
wow.
And ever since then, obviously, the hurricanes have increased and have gotten even more dangerous. Before we get deeper into your scholarship, let's talk about coming to LaGuardia. So how did you end up coming here as a faculty member?
Okay, so first, let me say that I didn't automatically know that I wanted to teach.
Right.
For some reason, as my advisor and colleagues, now colleagues, but before weren't colleagues, as they saw me explain certain things um, that I might have learned in their classes, for example, or that I may have been trying to teach myself by way of looking at different journals and looking at these many different sources, and now taking that knowledge and turning it and being able to explain it to someone else. Everyone kept telling me you should consider teaching, and in my mind, I'm like, why? Like, and they said because you're someone who does it really good. You take the time, the patience to really see what it is that the student, and in my mind at this point, is not really the student, right? It's just someone I'm having a conversation with. But as long as someone is learning, then in essence, they are a student. We are students, right?
Right.
So I then decided, you know what, let me just teach a course. So I taught thermodynamics at City College. And this is while I was doing a postdoc. Um, this is while I was doing a postdoc that was finishing up. I got a postdoc via the National Science Foundation, a fellowship that allowed me to do my research in Puerto Rico for 2 years. And so when I wasn't in Puerto Rico, I was in New York, and I just decided that I would teach the course. So as soon as I started teaching, I just loved it, and I enjoyed it. And so as an adjunct, I said, you know what, let me see if I could teach another course. So I took on fluid mechanics as well, taught fluid mechanics and thermodynamics in the semester. And I was, as I stepped into it, I thought that it would be difficult, and teaching is not easy. So in a sense it is, but I enjoyed the the work that I had to put in to bring my mind to a place where I could understand this further, and then be able to explain it to others and
Yeah.
assist them and see them through the process. So that made me enjoy. And then as I moved forward with the adjunct thing, I said, you know what? I'm from Queens, really. I mean, I'm from England, right? And I'm from Guyana as well.
Right.
My parents, but I'm from Queens. So let me see how I could connect my my path back full circle at where it really counts. So I looked at a lot of community colleges, and LaGuardia was one of the most prominent that I had listed. So when the interview came around, I said, "Let's go. Let's make it happen."
What's the neighborhood you grew up in Queens?
Oh, right by LaGuardia Airport, actually, East Elmhurst.
Okay, very good.
Yeah,
Yeah.
but I lived quite a few different places within New York City and outside of New York City as well.
Right. That was just so. I mean, that's pretty close to the college. So, and what year was that? That was what about how many years ago was that?
So I started at LaGuardia in
Right.
2018.
Okay.
So fall of 2018. And I remember a conversation that you and I had during opening sessions of that at that time. You told me stay the course.
Did I really?
Yeah, and I just never. You might have forgotten it, but I haven't forgotten it. You know what I mean? So
Well,
it's
yeah. I mean, what's interesting, and I don't know how much we want to get into this, but uh, one of the things that makes you an exciting guest is, first of all, you're a science professor, and which in the United States they talk about this, that it's students don't necessarily aren't pre-inclined to the sciences. So that's one thing. But you're also a man of color in the sciences, and I don't know if you know Sultan from Natural Sciences, who his last name, I'm losing his last name, but he talks about this too, where trying to encourage people of color, men and women, to get into the sciences because to increase those numbers. And one of the easiest ways to do that is to be a person of color in the front of the classroom. When
right.
a student walks in and they see somebody that looks like them or sounds like them, that, and suddenly they can walk out of there and say like, wow, I could do that.
Right.
Like
Representation is real.
this is
It's,
possible. But
yes.
I also know that as a faculty member of color, the all the pressures that people are facing increase for us because of the fact that, for example, they need you on a committee because they need, for the diversity's sake or whatever it is, or and that just happens over and over again, and so
Mhm.
the workload is greater. And sometimes I don't know what your experience has been, but sometimes we don't feel as welcome in the community necessarily
Mhm.
for whatever reasons. Whether people don't approach us to include us in the process. So I know that, and I'm particularly sensitive to it because where CUNY has done a lot of work in trying to recruit folks of color, they have not done as good a job at keeping them.
Right.
And in fact, we lose faculty of the underrepresented groups, let's say, faster than we can hire them. And
Mhm.
I can't help but think it has something to do with this notion of feeling welcomed and feeling, seeing
That's
yourself in the place and also getting the support that's
mhm.
necessary to succeed.
That's absolutely important. Yeah.
And so
Um,
that's something that matters to me. And so to have a faculty member in the sciences of color, uh, you know, that's something I want to support and I want to see succeed. Someone I want to see succeed.
I
Uh,
appreciate you. Thank you.
Yeah, because of and again, because and I always bring it back to student outcomes. People think like Hugo wants to do all this, blah, blah, and it's like it's all about it comes down to student outcomes. And so again, our population, you look at our student population, and so I want to see those folks feel like they have the possibility to succeed, and in areas that the numbers aren't so as high. So it's important to do that. But I want to talk about in you came in and you obviously, I mean, I don't know how this works in the math, engineering, and computer science department, but do they hire folks looking for specific specialties, or was it like kind of a general call?
So the specialty in the case of my hiring was for engineering.
I see.
It wasn't specific to the atmospheric science work that I do,
Right.
but it was engineering. And so
Uh-huh.
as a mechanical engineer,
Right.
I'm right at home. These are courses that I've taken or taught myself, all the way from undergrad through masters, as well as some courses I took during the course of my PhD. Not that I'm teaching PhD level courses or master's
No.
level courses here, right? But I have the experience of walking through that from the student side, and I actually taught undergrad courses as well in the field of engineering.
Right. And so typical and so when you are teaching in the department, what are some of the classic classes that we all develop our repertoire?
Mhm.
What are the ones that you teach?
Okay, so I teach introduction to engineering. So that's as soon as students jump in to the college, now they're exposed to what engineering is if they hadn't known it before, right? And
Right.
what are the standards that are expected? How do you analyze a problem? How do you go through the problem and then show the support or the non-support of the theory, right?
Right.
And how to strategize and to present your work, but not only present it, but to to critically think, right? And then be able to express what it is that that experiment that you just went through
Right.
teaches and how it connects to what you're learning in the class from the theoretical standpoint.
How do our students do in that class? How do they on
So
average?
So, I mean, it's difficult to say on average, right? But what I will
Right.
say is this: the beginning of the semester for any course is a lot different than the middle of the semester
Of
and the end
course.
of the
Yeah.
semester. So if I give a report or I assign a report where you have to work on this robotic arm, and design this robotic arm, program it in a way that it does a particular task. And I want you to explain what you did, what errors or what issues you had with it, and how you would move differently in the future. Then, if I assign that at the beginning of the semester, even though I told you everything that you need to do and where you need to go, you may not necessarily believe that I'm going to grade you how I say that I'm going to grade you. So you might leave certain things out. And then when you get your grade back, you say, oh, he was serious about, making sure that my references are formatted in a certain way, or citations, for
Right.
say citations, right? But by the middle of the semester, these things change. So I look at it in terms of every class is different, and the pathway for every class is different. But I do notice improvement from the beginning to the middle to the end.
Yeah. Yeah. I'm going to say something about that, but first I'm going to take a station break.
Okay.
You're watching and listening to LaGuardia Web Radio, WLGR. The show is What's Going On. I'm your host, Hugo Fernandez, and my guest today is Dr. Nathan Hosannah, who's an assistant professor in the math, engineering, and computer science department here at LaGuardia Community College. And we're talking about teaching. And I go through this very same thing. I basically give the same assignment over and over again. And by the end of the semester, they give me what I want. But in the beginning, of course, they don't. They struggle with it. And I just have to reinforce it over and over again. Like many of the same things you talked about, referencing their information, uh, you know, trying to really look at something a little bit longer than just a second and try to figure out what's going on visually, because I teach fine art and photography. Uh, Also, when they come across things that they didn't know before, they shouldn't expect that others would as well. So, annotating
Exactly.
as well, and also illustrating. I like to have them use images. So, but it takes us about a semester until they figure out what I want, and it's typically not what they would have necessarily done in an English class or some other course. They have to adapt to me, but they're adapting to the discipline. Like many ways that you were saying. I'm sure you don't use the Modern Languages Association approach to references. I'm sure you probably have the scientific version to that,
Right.
and
Exactly.
and that's good. You want to talk a little bit? What are some of the other, besides the introduction
Yeah.
course?
So that's what I
What other
wanted to
courses?
express. So I also teach electromechanical devices, which connects the theory of motors and generators of different types to the equations that govern them, and how you can, for example, connect a motor to a generator and then get that generator to produce electricity for another purpose, for example. So electromechanical devices, I teach instrumentation, which goes into the details of how these sensors that we used are broken down. What is the purpose of any sensor? It is to take a physical situation that's going on in the world, detect it, amplify the signal, and then run some calculations, and then display a result to you on the back end. So
Right.
that's another course that I teach. Actually teach instrumentation 1 and 2. Um, I taught a senior design course as well. I only did that 1 semester. I taught first year seminar as well. So the wheelhouse is expanding. Computer electronics. So I'm
What's
just
your favorite one of all the courses you teach?
um, you know what? I really like instrumentation as well as electromechanical devices. The reason why I have to mention both of those. Instrumentation, I've given assignments where students actually have had to create physical sensors based on what we go over in the class. One group of students, when we were actually in a physical space, they decided that they wanted to make a weather station. So we used Arduino, which for those familiar is or unfamiliar, is like a small computer that allows you to access and acquire data to different sensors and then be able to display it on the back end. So next connected to the Arduino are a bunch of different sensors. So they had a temperature, humidity sensor, a wind sensor, and a dust particle size sensor. So they connected all of these sensors. Then they ran their experiment after creating this device. Their experiment was comparing Saddlebrook, New Jersey to a place on the coast, so like Far Rockaway, the same day, the same time. So they had two sensors or two instruments, and this was a group of four students. So two were in one place, two were in the other. They ran it at the same time, took the data, compared it, analyzed it, and and then made some some points based on their findings and their analysis
Right.
of the data. But I also like electromechanical devices because it forces you to look at things that you use on a day-to-day basis in a new way, right? So like, what is a DC motor? Like how does it operate? How does it incorporate the magnets and the magnetism in order to produce current? And vice versa. So when we were actually physically in classes, I would have students make a hand wound generator. I would have students make their own DC motor. So I really love those courses where students have to get hands on because now they are able to apply that hands on learning with the theory from the book. And that just takes me back to aviation.
Yeah. And it's fun. I talked to somebody about this before. When I was running after school programs in the Bronx, I had a second grade principal, and I was talking to her about, we were supposed to be doing homework help, and you know, obviously one of the things they had to do is math, and she says, "Well, do you have manipulatives?" And I said, "What are manipulatives?" And she says, "Well, if you don't have manipulatives, you're not doing math." And what she meant was basically like little things that the kids could use to count. So again, this idea of taking it from just these abstract numbers, 3 plus 4, and
Right.
having a physical little 3 things and 4 things, putting them together, and now there were 7. Then she said that, and I think that applies even when you start, as however complicated the math gets, or the science in this case might get. I wanted to give you some time to talk a little bit about your scholarship.
Okay.
Uh, so tell us about what you're doing in Puerto Rico with the atmospheric science stuff and aerosols and the things you're studying, thermodynamics.
Absolutely. Much obliged, by the way, for giving me the opportunity to expound on this. So, so as I said, after I got my PhD from City College, I said, I need to kind of connect more to the Caribbean. I expanded my outlook, and it wasn't just because I wanted to be on Crash Boat Beach in LaGuardia in Puerto Rico. Right? That was a benefit to it.
Yeah.
Um, but I wanted a different experience. I lived in New York since I was 3. So I took a postdoc and just lived in Puerto Rico for a year in a place called Añasco on the West Coast next to Mayagüez. And I worked with the University of Puerto Rico at Mayagüez. And the study was how, again, these multi-scale processes impact local weather conditions. So what happens in Mayagüez is that you get a lot of rainfall in the afternoon hours, particularly in the summer. So a lot of thunderstorms, particularly in this region. And what is the reason behind that? Well, first, there is elevation. So the higher you are, the more air flows over that elevation, and that moist air can condense, and then it becomes water droplets, which then produce rainfall. But in addition to that, you have, as you were talking about the Sahara winds, I will say the easterly winds because that's the predominant direction of those winds coming from the west coast of Africa and just moving along the equatorial belt
Right.
towards the west. And so those are the dominant winds. But you also on the west coast have a sea breeze once the surface of Puerto Rico heats up.
Yeah.
So now you have warm air that rises over the island. The sea breeze on the west begins to replace the air that was moving aloft, and you still have that predominant easterly wind. So when they meet each other, they further fuel the mechanism to push the moist air upwards, and you end up getting these really intense thunderstorms in the summer that can produce flash floods and so on. So
God.
that
Yeah.
was what I wanted to focus on. And then
Right.
a lot of other things came into play, like Hurricane Maria and how the effect of Hurricane Maria, not only, a lot of people died from Hurricane Maria, but not only from the hurricane itself, but in the after effects of Hurricane Maria.
Right.
Right? But what also happened is that the land surface was modified. So in places where you had a lot of trees, you had like the foliage, or the leaves from the trees being taken away. You had trees being knocked down. You had the surface properties changing. So if you have the surface properties changing, then the interaction between the surface and the atmosphere changes, which can impact rainfall, which then impacts you getting the rainfall that you are used to receiving in a particular municipality, right? Which then
Right.
can cause issues of shortage or inundation.
So here's a question. From your research, how do you what what do you expect people to do with this? I mean, how I don't want to commodify it, but I guess I am. I'm saying like, how does what do we make of it from what you're finding out? What are some of the are you is it to encourage uh, nations, let's say, to take actions to prevent possible future catastrophic events, or how do you see utilizing the research?
So when I begin to jump into any type of research, the question I ask is, but why? Like
Right.
why is it useful? Who is it serving?
Exactly.
So when we're talking about rainfall across an island, and Puerto Rico is kind of a bigger island, right? But you also have these smaller islands in the region that are impacted by these local um, rainfall characteristics.
Yep.
And anything that can modify rainfall modifies the production of food,
I see.
right? Modifies the amount of rainwater that you get, which can then be potable water, right? And it also impacts the quality of life, right? So, from a very person-based way of looking at this, that is one of my major reasons. But in addition to that, understanding the circumstances that lead to extreme weather events can now help us to predict them better. So this information can now be fed into prediction models, such as you may see on your Doppler 4000 or 10,000 or whatever number it is right now, and
Right.
they are better able to determine what is truly going on and what is likely to happen with the more data that you get and the better understanding that you receive via your study.
And that's pretty important.
Yeah, right.
Speaking of somebody who lives in New England, and all we get is weather, and I mean, my wife has one program, and she'll know more than I will. I just use the phone tells me when it's going to rain or when it's not going to rain. But I
Mhm.
mean, we had a pretty eventful summer where we had obviously the hurricane that came, but we caught, we it manifested itself here as tornadoes, and different kinds of rainfall. I mean, we had several weather events where we lose. For me, the definite. I know it's an event when we lose power, and
Right.
that's why I want to get myself a generator, so I can at least not have to deal with that, deal with
Absolutely.
the disruption which that causes.
Did you,
But just being somebody from the Caribbean, like when you were talking, I can just see how important
yeah.
the work you're doing. And are you engaged with any of the folks, like Noah or any of these folks? Are you interacting with them at all?
So the interaction, uh, as I mentioned earlier, I did a fellowship that involved interaction with NSF, and some of my
Nice.
collaborators also that I've either put papers out with or did the weather campaigns that I've done in Puerto Rico, known as the convection aerosol synoptic effects in the tropics, shorthand acronym version CAST, right? So this was a field campaign on the west coast of Puerto Rico that was implemented to add additional sensors to be able to kind of zoom in on what is exactly causing these rainfall events that I spoke about previously.
All
So
right.
I worked with folks from Purdue who have connections with NOAA. I worked Purdue University. I worked with folks from San Jose State, from with people from Howard University as well, from Arizona State University, who are connected to NOAA in many different ways. At this particular moment, I am not involved with NOAA, but as an undergrad, as I was not an undergrad, as I'm doing my PhD, I my funding was through NOAA Crest. So,
All
you
right.
know, everything that was weather ready event and making sure that weather ready nation and making sure that anything that I was doing related to research connected to those particular goals that NOAA sets.
So, and your science can save lives, right? That's what we're talking about here. I mean, a mudslide can wipe out an entire community
Yes.
uh, very quickly. Uh, so this is good work. We're moving into the last quarter hour, and Dr. Riccio is manning the Twitch stream. I don't know if anybody's got questions. Uh, this is what I really talk about. I give my guests an opportunity to talk about the future, and what are you looking at moving forward with either your research, your teaching, or hell, how are you doing in your tenure and promotion process? I always check in with folks,
Mm-hmm.
because it's like you're moving on 7 fronts at once. With
Yes.
service, of
Right.
course, is something else. Dr. Riccio is saying no questions. We're competing. By the way, we're competing against a lot of folks today, but I'm guess we get a lot of folks who watch us through the archive as well. So,
Mhm.
but the future, what does the
Yeah.
future
So
hold?
so I'm in. This is year 3 now for me. So I'm beginning to focus on the transition of preparing myself to create the best possible application for promotion to associate professor. Um, and so just keep my eyes on the prize with that. I have great colleagues in the engineering program as well as in MEC who have given me some advice as to how to get those documents in and how to arrange things and to constantly update your personnel files,
Right.
right? But also to do things and speak about the things that you're doing. Oftentimes we do a lot of things that are important and we just do them. We don't think to really express what we're doing. And
Toot our
so
horn. Yeah.
yeah, so it's important to toot your own horn, as you said. So that is major on my plate right now. That is at the top of the list. Um, research wise, I just submitted a revision to a paper that was based on the Hurricane Maria stuff that I was telling you about. about how Hurricane Maria altered the landscape and how that can then affect local rain events, as well as preparing to write for something for the impact of the local environment on Guyanese, on weather in Guyana as well.
Mm.
So that is the next 2 years. I also am in the process of um, looking at some proposals for NOAA with some colleagues at the the college, and I just have to really express the gratitude for having met Dr. Man Hamilton, Ryan,
Yep.
because he's a sharp guy. He's an intelligent dude, and he's always on the pulse of what is happening in Puerto Rico, as well as how it relates to the environment. So we have a lot. We get together and we have a lot of conversations um, around that. So the focus is writing proposals to be able to do some of the things that I'm thinking about along those lines. And then as far as the teaching is concerned, it's interesting to be in this phase where everything is online because you're seeing that students are having a difficult run of it being online. Students like the physical classroom, and I like being in the physical classroom. Obviously, that's not something that isn't possible right now. So the goal moving forward is if this online or distance learning is the way that things are to be for the immediate future, then continually getting better at that. One of the things that I've implemented this semester is the idea of running a process, having students generate a process analysis, which is a classroom assessment technique where students pretty much log everything that they do in the group and they analyze it. They determine which steps are taking too long. They have to answer to themselves, so to speak, and the tasks that they're doing. So I look at the process analysis, implement that within the group work, and for now it seems like it's beneficial because it's forcing students to really think about what they're doing instead of trying to get something done for the purpose of handing in an assignment.
Right. Sounds good. It also sounds like you've got a lot of support, which is important. A lot of
Yeah.
collegial support. I don't know. Do you and talking about Ryan? I don't know if you necessarily see it as a mentorship, but that's also very important.
Yeah, so as far as mentorship is concerned, the professors in the engineering department, I have to tip my hat to them. You know, in the engineering program of the MEC department, um, Dr. Ngabonziza, Dr. West, Dr. Easy, Dr. Delcan, you know, Dr. Hasibo, you know, even the MEC chair has been like really, really connected to my success and what it is that I'm doing, Dr. Belcaraz. And then there are a bunch of people within, you know, the MEC department. I can't name them all, you know, but Dr. Zay, um, Dr. Darabsa, you know, I could go on forever and ever and ever and ever and never stop. Dr. Yao, you know, you got to stop me because I'm just going to keep going.
Sometimes what I do is back when we were physically on campus, I just go down the hall and try to remember them room by room as I walk past them. But yeah,
Mm-hmm.
you're right. It's a fool's errand to try to name everybody who's had an impact on us, and you always leave somebody out. But
Right,
it's
exactly.
just not. And again, I'd just say that getting support is a really important part of this. And when you were talking, Ryan, I know that Ryan is working on the President's Society's environmental group, and they're doing work behind the C building. Obviously, they can't do it now because of what's going on with the pandemic, but if they ever get back there again, and be interesting to see the two of you, coming at it from two different directions, talking about the weather here in LIC. We have a very peculiar kind of, I swear it's as windy as the west side of Manhattan, if not more so, particularly the closer you get to the C building and the Citibank building. It's get some pretty high winds there on Thompson and Skillman.
Right.
But we're winding down, and I want to give you an opportunity to any last words and to thank anybody else before we have to close.
So first and foremost, I would like to thank you for having me on the show, as well as Jamie and Christopher. I would like to thank the support that I was not. I don't want to thank the support, but I would like to thank the MEC department for supporting me in my movement towards promotion, tenure. I would like to thank people from way back. Like I said, there are just too many to name, so I'm not going to do the disservice of trying and then missing out on people anyway. But I'm just thankful for the opportunity to speak, to listen, to learn, and to grow.
Yeah, it was funny because when like I said, when you said you wanted to be on the show, I said, "What do you want to talk about?" You said me, and I said, "Okay, that sounds like a show." And again, I think it's important to give voice to someone who's in the process of this. We all go through this, and it sometimes it seems like it's very isolating. Like we're all in our own place with the tenure and promotion process,
Mhm.
and we're all going through the same thing. And that's why it's so important to share about it. For you to share your process. It sounds like you're doing pretty well though with your scholarship, and you sound like a great teacher. And I mean, I know you and I are both be at the faculty council meeting, which is
Mhm.
certainly a place where we could start looking at being, you know, uh, college-wide service, which is another thing that we're looking
Right.
at. And you're a great guy. You're a nice guy. So collegiality, check, check, check. Have you been yet as part of done the provost learning space? Is that something you've done yet?
Yeah, I've done that. I've done that. It was useful, and that's kind of where I decided to implement the process analysis
That's a
component.
good one. Yeah.
Yeah.
As I say about that is like, once you're in the provost space, you're always like the CIA, you never leave as because you'll see that every time you write your evaluation, they'll want to know where are you with that.
Right.
So, but just listening to you talk, I think about implementing some of these ideas in my discipline, and that's I think one of the saddest things about uh, working in such a big place is that we don't get to engage as much. CTL has always been good for that. We meet people in cross disciplines, but this is, I guess, another opportunity to do it here to bring people on and find out what they're doing. And but I'm sad to say that we're running out of time, and so I just want to say thank you to you for coming on the show and sharing and being sharing about your process and your ideas. I've learned something. And I'm not an engineer, but I'm a teacher, and so when you were talking about all those aspects, teaching and uh, I got something out of it. So we all learn wherever we are in our process. We just got to be open to learning. And I want to thank everybody for listening. Uh, you've been watching and listening to what's going on here on LaGuardia Radio WLGR. My guest today has been Dr. Nathan Hosannah, who is an assistant professor for now in the Math and Engineering Computer Science Department. Hopefully, moving on to associate in the spring. Are you going up? Are you going to go up for promotion in the spring?
So I
Or
know that I have to. Well, this is the beginning of the third year, so I am going to put in the application for the spring
right on?
for the next year. Right.
Yeah, talk to Abdel. He'll tell you what to do.
It, They'll definitely he gives game, like he gives a lot of information.
And you have to listen to your chair. That's the number
Absolutely.
one thing. So thanks for being on, and thanks for watching. And Mr. Pope, take us out as we came in. Bye bye.